Should I try that drug or not? Yeah, give it a shot. What are the chances it's going to be bad for me? Not that high.
Charge up your axons, ready your receptors, and shift your lobes into upper beta phase. You are listening to Smart Drug Smarts, the podcast dedicated to helping you optimize your brain with the latest breakthroughs in neuroscience, nootropics, and psychopharmacology.
Hello and welcome to Smart Drug Smarts. My name is Jesse Lawler. I am your host, and this is the 198th episode of this podcast dedicated to anything and everything that you can do to improve and better understand the workings of your own brain, and in some cases, also the brains of those around you. Humans are social creatures, and understanding the brains of those in our social groups definitely comes in peripherally handy. You could lead a horse to water, you can't make the horse drink, but if you understand something about the horse's brain, you might be able to figure out a way to motivate that horse. Or in the case of this episode, a human teenager. And this is an episode I've wanted to do for a while, looking at the teenage brain, something which is widely recognized to be a work in progress. Teens take a lot of flack from pretty much all other age groups, some of which may be deserved, but probably not all of which is. There's obviously a lot of changes going on during the teenage years. But there's sort of been this pervasive feeling that the teenage brain is somehow inherently broken compared to the periods of life both preceding and following it. But it may not be as bad as all that. Teens might be actually on a cognitive upslope compared to younger kids if we look at things in the proper context. In this episode's main interview, I'm going to be talking with Dr. Daniel Romer about something he calls the lifespan wisdom model, pretty much a scientific defense, or at least a theory in defense of the teenage brain. I find it pretty compelling. Not everybody does, but we'll hear about the pros, cons, controversies, and why teens are the way they are in the coming interview. We probably don't have a lot of teenage listeners to this show, so I'm not expecting this to be directly beneficial, but there's probably no small number of parents, and if you deal with teens on a regular basis, you know what Sun Tzu says, know your enemy and know yourself, and you will always be victorious. If you hang around until the very end of the episode, in the Ruthless Listener Retention gimmick, I'm going to tell you how even some species of worms have predictable troubles in their teenage years, or the worm equivalent, since their lifespan is obviously telescoped down from ours. But for right now, let's kick things off as usual with This Week in Neuroscience.
Smart Drug Smarts, This Week in Neuroscience.
So back in late August, a lot of us were lucky enough to see a partial, or in some cases total, eclipse as it passed over the US on August 21st. There was one research scientist, a professor of neuroscience at Ohio State University named Stuart Mangle, who traveled to Tennessee to see the eclipse. And according to him, during the total eclipse, it was as dark as it usually is at dusk. Several people that I was with commented that they could see as well during the totality as they could when it had been bright, and that their visual acuity was much better than it usually is when it's dark at dusk. And at that point, the metaphorical light bulb went on for him that what people were experiencing during the eclipse actually had some bearing on research that he'd published recently in the journal Current Biology. There's a protein called a GABA receptor, yes, that GABA, gamma-aminobutyric acid, and this protein is abundant in the eye's retina on sunny days, and it helps with the ability to see fine details in objects and pick up their edges. And the presence or absence of this protein varies with circadian rhythms throughout the day. It drops away at nighttime, meaning we don't have as much visual acuity, but that can actually be helpful for helping us discern large, dim objects on moonless nights, says Mangle. It's been known for decades that there's a mechanism in the retina that helps us see small objects and detect edges on bright days, and that this mechanism gradually turns off when it's dark. However, what this mechanism is and how it is controlled has been a mystery. Mangle's study was conducted in rabbits, and he also found the telltale fingerprints of the neurotransmitter dopamine, which increases in the light, decreases in the dark, and regulates whether the GABA receptor protein works within the retina. My findings show that the change in background light triggers a process in the retina that normally takes hours. This process involves assembling and moving the GABA receptor protein to a specific site in the retina when it's bright, and disassembling the same protein and moving it away from the synapse as it becomes dark. And this, he says, explains the perceptual oddities that people saw during the eclipse, probably also because there was a lot of dopamine flowing during the eclipse because everybody was so excited about it, but also, of course, just because the darkness came on fast, says Mangle. The reason that our visual acuity stayed high during the total eclipse is that there just wasn't enough time for the protein disassembly to take place.
Smart Drug Smarts, the podcast so smart, we have smart in our title, twice.
Picked up a couple of 5-star reviews on iTunes. Listener Jackerman47 from the USA says, super informative and fun to listen to. I've been listening for a month or so now, and I've gone back through all the old episodes checking out the stuff I'm interested in. And Working Joe 2001, also from the USA, says, a friend just recommended this podcast to me, and I love it. Lots of up-to-date medical health info in an easy-to-understand format. Well, thanks to both of those, and thanks to the anonymous friend who recommended that Working Joe 2001 listen to the podcast. That is exactly the kind of word-of-mouth do-gooderism that I like to encourage. There's Facebook ads, there's invisible pixels that can track you from one website to another. There's all that stuff, but nothing really carries the same weight as a human-to-human recommendation, so a big thanks to everybody that's been helping to spread the word. If your friends happen to be the type that enjoy reading more than listening, I'm not sure if those people exist anymore, but if they do, you could always forward them a copy of the most recent Brain Breakfast, the Smart Drug Smarts newsletter. That's assuming, of course, that you're subscribed yourself. If you're not and you want to be, you can sign up for that at smartdrugsmarts.com/newsletter. Get the latest, the greatest, and sometimes the upcomingest of the things that we're reading and talking and thinking about behind the scenes here. Those come out every week or so, taking a page from psychology and doing the random positive feedback. You're never exactly sure how frequently brain breakfasts are going to hit, but hopefully the occasional absence makes the heart grow fonder. A big thanks to the fine folks over at axonlabs.io. Just had an upgrade this past week to the product page interface. As almost inevitably happens every time there's a major technical change, there was one part of it went haywire, which in this case was definitely in the customer's favor. There was a pricing glitch, and at least one or two people got through the gates with a huge discount that was not really intended on buying a multi-pack purchase. So hats off to them on the inadvertent sale. That particular deal is no longer available, but nevertheless, still some really good deals to be had on multi-pack purchases and subscriptions of Nexus and Mitogen. Intentional or not on those particular deals, which was something like 60% off, I think, when all was said and done. That is actually the kind of thing that happens regularly on the Vitamunk launch list. I've talked about this before. Vitamunk is another kissin' cousin of Smart Drug Smarts, and they have what's called an email launch list. You can sign up for that and get notified every time that they've got a new product that they're releasing. The deals offered to that list are truly ridiculous. They're real products. They're not fell off the back of a truck style supplements or anything like that. They are just using some outrageous discounts put out to that list to placate the Amazon algorithms when they launch a new product, which eventually leads Amazon to start doing pushing on their behalf. So it's kind of a clever strategic move, but they are clever people over there, as you might imagine, very much into brain health and body health, and definitely worth checking out vitamunk.com in general. And if you want to get onto that launch list, you can hit smartdrugsmarts.com/launch. Finally, as we're getting into the tail end of 2017 here, the end of the year is in sight. I want to put out a call for requests, recommendations, anything that you'd love to hear an episode on. It probably won't make it actually into this year's lineup. I think our dance card is pretty much full, but looking ahead to next year, we can start planning those interviews. So any particular ideas or requests, drop me an email, jesse@smartdrugsmarts.com.
Smart Drug Smarts.
So I'm about to be speaking with Dr. Dan Romer, who is the research director of the Annenberg Public Policy Center and the director of its Adolescent Communication Institute, all of which is part of the University of Pennsylvania. His research focuses in large part on media and social influences to adolescent health, including the social transmission of risky behavior, peer pressure, dirty jokes, all that stuff that we associate with teenagerdom. He's done work with the National Institutes of Health, the National Science Foundation, the National Institute on Drug Abuse, and pretty much a who's who of groups that are trying to find ways of raising healthy, mature, happy teens in developmentally responsible ways. Figuring out what those ways are if the modern world is inherently problematic for teenage brain and social development. And as you will hear in this interview, depending on what your particular stance is on teens, you might call him either a teen advocate or a teen apologist, but he's definitely found a way of threatening the dominant paradigm of how the teen brain is viewed. His recently published work includes something called the Lifespan Wisdom Model, which is sort of a reconceptualization of what's actually going on within the teen brain as it develops, specifically with regard to risk-seeking or at least risk-tolerating behavior. It might not be as wild as it sounds, but we'll let Dr. Romer explain in the coming interview. So let your hair hang down into your eyes, crank up your earbuds so loud that you can't hear your parents yelling at you, and enjoy the coming interview with Dr. Dan Romer.
Back in the early 2000s, research was starting to come out, some of it done by the National Institute of Health, very reliable, trustworthy source, suggesting, based on brain scans, looking at young people from like ages 8 to 30, and scanning their brains across this age period, what became clear was that there were relatively dramatic changes in the structure of the brain over that time period. It's not that the brain got any bigger or smaller, it's that certain structural features of the brain were changing, the most interesting of which was a decline in what appeared to be the gray matter, what seemed to be a pruning process. So we actually lose gray matter as we age through adolescence, and an increase in white matter. And white matter is the myelinated fibers that surround a lot of neurons and enable fast communication between different parts of the brain. So it looked as though if you just took that at face value, it wouldn't be clear what it meant. And so when it was first presented, it was sort of suggested that, well, this is a sign that during the adolescent period, the brain is learning and assimilating information. And so we prune the parts of the neuronal structure that we don't need anymore. We keep the ones we do. We increase connections between them. And the brain myelinates to enable faster connection. And that was the initial interpretation. But then, sort of in the middle of the 2000s, some neuroscientists and developmentalists came to the conclusion that this could be an explanation for why adolescents engage in a lot of risk-taking. And of course, risk-taking in the negative sense, using drugs, unprotected sex, driving in a way that's not safe, things like that, things that cause injury and harm. There was no clear reason for that. A lot of neuroscientists started doing research, looking at brain differences, activation differences in relation to what might be called risk-taking behavior, at least in a laboratory. And they came up with some studies that suggested there may be some validity to that. And so the teen brain suddenly took on a new meaning in the sense that it wasn't fully developed, and this myelination process in particular didn't look as though it was complete until, mid-20s or so. And so it became popular to say the adolescent brain was undeveloped and, by implication, unable to control its behavior, the behavior that's driven by the subcortical part of the brain, the part that creates emotions and drives for behavior, sex and drugs, things like that. That was assumed to be fully developed by the time we got to at least mid-adolescence, whereas the upper part of the brain was still developing and would continue so until at least the mid-20s. Then we had magazine covers talking about it. It must have been several Time magazine, National Geographic, all of these popular culture magazines picked up on it. And it became part of the culture that the adolescent brain is not fully developed until 25 became the magic year. And therefore, that's why adolescents do all the dumb things they do. And then there's the implication that we shouldn't let them loose, basically, because we got to watch them, keep them home down on the farm, that kind of attitude.
Yeah.
Because if we let them out, they're going to do all these dumb things because they can't control themselves. And we just have to wait until their brains have fully matured before they can become fully functioning people. So that's sort of the backdrop of where we come in. And we're not the first to sort of question that, but I think we put together the evidence that suggests that interpretation may be a bit of an overstatement and actually be driven more by stereotypes than anything else.
Funny, because when we think about the quote-unquote bad things that teens do, sex, drugs, and bad driving tend to be, I guess, probably the big three. And in an ancestral environment, the vast majority of drugs weren't available. Having teenage sex when you were a cave person probably wasn't a terribly maladaptive thing to do. And obviously, bad driving wasn't an option you had. You could chase the woolly mammoth faster, but that was about it. It's interesting that none of these things that are the big red flags in modern society would have really been all that bad, I guess, in the environment that our brains developed for.
Well, that's one of the arguments, that this is evolutionarily, it was adaptive because having sex at age 15 wasn't such a bad thing when you lived in a cave. And maybe there weren't as many drugs around, although that's probably debatable. I'm sure there were all kinds of hazards that would be present for an adolescent, even in evolutionarily speaking.
There are certainly ways of getting yourself in trouble. I guess since this is a human universal that teenagers are risk-taking, intuitively there must be some sort of adaptive advantage to it, or it would have been smoothed out a long time ago.
Yeah, for sure. And some of the people who were pushing this point of view started to soften their way of talking about it and saying, well, it's probably evolutionary adaptive, but it still creates a problem, especially in the modern context. So I think the people who proposed this model kind of started to soften. But you still had some of these folks still talk about teenage drivers. You put them together in a car. Next thing you know, they're going to have an accident. That kind of scare is still talked about. Adolescents can't control themselves when they're together with each other. Here they are with their unformed brains, and then you put them together with each other, and next thing you know, they're going to be even more out of control. So there was always another side of it that would accentuate the downside of risk-taking. And of course, the whole point of talking about risk-taking was always in the negative sense, as you said. There's a lot of risk-taking people do that, if you don't do it, you're never going to get out of your cocoon, become an adult.
Yeah, it seems like that's part of the defining of one's sense of self needs to be taking the risk of pissing off your parents.
Yeah. I mean, if you can't start doing things that your parents may not always agree with, that may not be the most adaptive way to transition to adulthood. You can't live with your parents and expect them to run your life for the rest of your life.
So tell me about your alternate model, your alternate hypothesis for brain development. You're looking at the same data but drawing pretty different conclusions. Tell me how that came about.
So one of the things we did was we looked at what exactly are adolescent risk-taking patterns like. If their model's true, adolescents should be more likely to take risks than children, for example, because they claim that this is a heightened period of risk, even worse than for children. So we looked at developmental patterns in risk-taking, and there's some kinds of risk where if you tell people exactly what the risks are, so for example, you can get $10 for sure, or I can give you a chance to get $20 with a coin toss. So you either get the $10 for sure, or you can get $20 50% of the time. That kind of task, very common. Adults will take the $10. They don't want to take the risk. Children are much more likely to take the risk, and adolescents are right in the middle. So they're not particularly more risky than children, and they're only slightly more risky than adults. They're not particularly strong in effect. So you get a pretty much of a linear, or what we might say a monotonic decline in that kind of risk-taking.
Are we talking even odds in this? So it's basically the expected value in both cases the same?
Yeah, it's just you have to wait for it. So being willing to wait is a sign that you're not impulsive. And that kind of response is correlated with other behaviors like using drugs and doing risky things. So it's a marker of risk-taking that has some real-world application, but it doesn't fit their model. Then there's another kind of risk-taking in which you don't know what the odds are of whether it'll be good for you or bad for you. That kind of risk-taking does seem to be higher in adolescence. So if you don't know specifically how this is going to turn out for you, which is different from these tasks where we know the probabilities, we know the length of time, we know all the parameters. If we don't know, that's where adolescents are more likely to take a chance. This is correlated with a phenomenon called sensation seeking. So adolescents experiencing novel things. Should I try that drug or not? Yeah, give it a shot. What are the chances it's going to be bad for me? Not that high. What are the chances that I'm going to get HIV from having unprotected sex with my girlfriend? Not that high. Do I know? No. And so those kinds of behaviors are more likely to occur with adolescents because they're novel, they don't have experience, and they don't know for sure how it'll turn out for them. And so they have an optimistic bias.
How do you test that in the lab? Because it seems like it's harder to test an unknown downside because you can't do anything actually dangerous with kids in an experiment. How are you mocking up that as a real choice?
Yeah, well, they do experiments in which they give people the option of trying the risky choice without knowing how it'll turn out. So it could turn out really good or it could turn out really bad. You just don't know. And when you do that, adults will hardly ever take that choice. They always I'll take something that I know for sure better. Adolescents are willing to take the risk if there's a good chance of a payoff. And in fact, it turns out that they're actually more rational in that regard because by not being so risk averse, they actually do better. They will lose out some of the time, but they will also, on average, they do okay. This is in laboratory settings.
Yeah.
And we also know just from drug use, things like that, adolescents are more likely to try a drug that they don't fully know what it'll do to them. They might know what it does to people on average or to their parents, but they really have no idea what it'll do for them. That's more likely in an adolescent than in an 8-year-old. An 8-year-old is going to say, ugh, I don't know, I don't want to take that. But a 15-year-old will say, yeah, I'll try a little marijuana or I'll try smoking a cigarette. Why not? What's going to happen to me? My uncle does it. So they're exploring. They're willing to explore. And so we argue based on that kind of evidence that what neuroscientists, when they looked at the brains of adolescents, they found they were likely to evaluate these unknown kinds of risk more highly, and the brains would reflect that. And they interpreted that as evidence for what was called an imbalance. The prefrontal cortex is not in balance with the subcortical part. And so we argue that that's just exploring and it isn't necessarily going to be harmful. Now, there is a form of impulsivity that is really insensitive to risk, and we know that happens because people get addicted to drugs and they can't stop themselves, and that can start in adolescence. Those kids who have that problem tend to be more impulsive, and you can see that even earlier than adolescence. It's a characteristic that you start seeing as early as ages 4 and 5, especially in conditions like ADHD. So ADHD is a very commonly understood, although not fully understood, brain development condition that has impulsive characteristics and puts a kid at risk for later having behavior problems, drug problems, things like that. That's a condition that exists prior to adolescence. All adolescence does is enable the person to do riskier things, especially if they're not being watched or not given stimulants, which can sometimes help to reduce that condition. So we argue that, there are kids who do that, and they may be more likely to be at risk when they're adolescents because the things they can do are riskier, and there may actually be a slight increase in their impulsivity.
Are the results that they're looking at there, is it drug use or really problematic drug use, drug abuse, where it's having a noticeably negative impact on the kid's life?
So kids that are exploring, they will use drugs, and at quite a relatively high rate compared to those who are not. This is an individual difference now, which tends to be higher in adolescence, but they don't tend to get addicted. The kids who are more likely to get addicted are the ones who have impulse control disorders, because then when they have a bad experience with a drug due to some effect that the drug has on them, not the least of which is failing to do well in school and then becoming unable to stop, which is a property of the drug. It creates this dependence. The kids who are sensation seeking don't tend to have that problem as much, and that's because they actually have pretty good cognitive control. So that's another piece of evidence that goes against this imbalance theory, because the kids who are doing the exploring are actually not so bad off in terms of their ability to control themselves. They're actually better off than the kids who have the impulse control disorders. The ones with those disorders tend to have poor cognitive control. And so when if they end up using a drug, they're going to have a harder time quitting. And this is true for tobacco or any other addictive substance. So the imbalance really is just in this subset of kids, some of whom have ADHD, others have other problems, or they may be growing up in an environment that doesn't train self-control, often for good reason. Like if you're growing up in poverty, you may not be so wise to be controlled, and it may be a completely adaptive kind of behavior in those environments. So it's not just a personality thing unique to the individual. It's something that can be cultivated due to the environment one is in. And so, there's all kinds of factors that can lead to that, not all of which are necessarily so maladaptive. So we basically deconstructed what it means to be a risk taker and found that the kind that goes along with being an explorer doesn't have a deficit in cognitive control. The kind that does have a problem, if they're exploring, it's because they're a minority of adolescents and they do have cognitive control problems, but they're really not typical. And there may not be anything particularly maladaptive other than for the explorers, other than that they might try something that could be harmful to them in the immediate case. But on average, they learn from it and don't have long-term problems. They don't have gambling addictions and drug addictions. They learn how to drive and control themselves eventually.
Right. It's not that you shouldn't burn your hand on the hot stove. It's that you shouldn't repetitively burn your hand on the hot stove.
Yeah, and the impulsive kids will have a problem more so with doing things that are unhealthy for them. So, and then, we also looked at brain data. There weren't that many, but there were several studies that showed that if you looked at the brain's development, it wasn't necessarily, this myelination thing. There was one study that found that the more myelinated the brains of adolescents were, the more risk-taking they were, not less. Or other studies found no relation. There's also a lot of research that's come out that shows that the brain networks that control behavior that are in the prefrontal cortex and connect with other regions, what happens during adolescence is they actually become more self-contained. It's not so critical for them to branch out and reach other parts of the brain. It's more important for them to become self-contained, because that's how the brain can concentrate and control itself, is if these cognitive control networks sort of look inward. So working memory, for example, is a very important component of cognitive control. The networks that control that become more what's called segregated as the adolescent brain develops. They don't branch out. They become actually somewhat segregated. But then later in adulthood, these networks become less segregated, and the interpretation, we don't fully understand it, but one interpretation is that that's a necessity for the brain to connect with all the things it's learned. So it's no longer able to control itself so well. So it has to rely on all the experience it's gained. And so as we move into adulthood and later, this is the part of our model that we attribute to what's called wisdom. And wisdom develops over time with experience. So if you explore when you're an adolescent, you're going to gain wisdom that will do you well later when your cognitive control capacities actually decline. Once you get into your late 20s and early 30s, you start losing some of these cognitive abilities. Working memory starts to decline. Short-term memory starts to decline. These are all standard biological processes having to do with, in part, with dopamine transmission, which peaks in adolescence and helps with the brain's cognitive control system. It also excites the motivational system, but it doesn't seem to be doing that any more than it enables the control system. But as we age, we have to depend on our wisdom. We can't depend on the ability to think and concentrate as well as we could when we were adolescents. So that's the other part of our model, is that there's a growth in wisdom, and we hypothesize that this wisdom is the component where there's really an imbalance. So adolescents just don't have a lot of wisdom. They're novices. Everything they do, from sex to drugs to driving to doing well in school and trying out for competitions, going into sports, all the things they're going to try, they don't really know what's going to happen, and they're really inexperienced, and they're going to find out. And that's when we find out if we're good at sports or if we're good at debating or if we can do math better than other people. And, all the things we find out about ourselves happens in adolescence and early adulthood when we do this exploring. And that's where we have a deficit, is in the experience component. But later, we gain experience and we don't need that ability anymore to think and concentrate the way we were able to do when we were adolescents. And so that's how we kind of put this all together into what we call this lifespan wisdom model.
And it feels like you're kind of standing up for the brain and saying, hey, adolescence isn't this pockmark on our mental development where things go south for a while. There's just a couple of different signals there that when you segregate them into separate piles, the well-known risk versus the exploratory risk, everything sort of makes sense in a progressive way.
I think so. It never made sense to us to argue that adolescents had a developmental deficit, even considering all the arguments about evolution and how our brains are now evolutionarily maybe maladaptive, which is one implication you would get because of modern society being so prone to having risks that weren't present back in our earlier evolutionary past. Aside from that part, it didn't seem to make sense that we would all be here and get through we get through adolescence, nearly all of us, pretty well.
I feel like adolescence gets a bad rap. It's like I remember being 9 years old, 10 years old, and already was hearing like, oh, it's so hard to be a teenager. Teenagers are so crazy. It's like they get this idea kind of sunk into their head before they're even there that it's going to be this really rough time. And I feel like if it wasn't advertised that way leading into it, it might not actually be quite so bad.
Yeah, I agree. I think we sort of stigmatize adolescents and stereotype them. And I think that's because adults have a hard time with them. Parents don't enjoy always the adolescent period, because the kids want to do things that the parents have had experience with that they don't think is smart or things that the parents do.
Yeah, it's okay for me, but not for you.
Yeah. And of course, the parent knows how to handle it, has had experience and can possibly control that kind of behavior better, or knows what to avoid. The adolescent's still learning all that. And it's difficult to raise an adolescent. And so I think adults are prone to this stereotype. The adolescent is a problem. They do things that are risky. They do things that we wouldn't do. They don't listen to us. They do all these things that are upsetting to parents.
You flip that the other way and you had a kid that never made any mistakes and didn't do anything wrong, then they would never get the experience of learning how to deal with a mistake or pull themselves up and dust themselves off. Mistakes are part of the process.
Yeah, I think that's true. And we sort of forget about that when we talk about it as a brain issue. This is a deficit in the brain, and then we have to protect adolescents, not allow them to do things, prevent them from driving and going out and having sex. And this perspective sort of says that there's probably some sort of ideal level of experimentation that parents should allow. And this is not a new idea either. It's been around for a while, called authoritative parenting. So there are parents who won't let their kids do anything. There are parents that will let their kids do anything. Neither of those are good.
Goldilocks parenting.
Yeah. I mean, the best kind of parenting is the kind that says, okay, you can go out, but I want you home at a certain time. And who are you going with? Putting some parameters on what they do so that the chances of them having a bad experience are minimized. And a good example of how this works in a policy level is graduated driver licensing, which came into vogue 10 or 15 years ago and is now shown to delay kids going on the road on their own and spending time with their parents in the car before they can get a full license. And that helps. It doesn't solve all the problems, but it does help. It does reduce accidents, and it's a form of authoritative parenting. You don't just let the kid have the keys and say, go make mistakes. You kind of gradually help them get to the point where they can drive on their own. And the same argument would be true, I think, for things like alcohol, which is so commonly used in our culture. It becomes a problem when kids go to college because they're not 21 and half the campus is 21. And so it puts kids in a funny situation where they have to drink undercover, and then that creates all kinds of problems. So I think this is not a popular thing to say, but I think it would make sense to allow kids under the supervision of their parents or some other adult to drink alcohol as long as they didn't overdo it. And you could argue that some of the things that happen that are bad with alcohol happen because the kids aren't being supervised and they're hiding.
When you push something underground, I mean, we kind of saw that with prohibition of alcohol for adults. It's like it created this whole criminal enterprise out of it. And it's not quite the same when you're just having to hide alcohol use from your parents, but it kind of does force all this dishonesty and stuff like that wouldn't need to take place if you could do it in the light of day as a teenager to some reasonable degree.
Yeah, I mean, I grew up in New York, and at the time when I was growing up, 18 was the age, and there were kids out who would go out on a Friday night and drink at 18 or even younger. And I guess what happened, well, we know what happened is in the 80s, the federal government, under pressure, for good reasons, I think, Mothers Against Drunk Driving were upset that a lot of young people were driving drunk, and adults as well. And there were no harsh penalties for that. So they started encouraging people to have a designated driver. And they also started encouraging government to make 21 the age that you could start drinking. And whether that has been a wise decision or not, I think is still up in the air, although many people think that that's been settled, that it has saved lives. On the other hand, the Canadians, their legal drinking age varies by province, but it's 18 or 19. That's the highest. And if you look at what happened with them, they also got influenced by Mothers Against Drunk Driving. They also had a decline in alcohol fatalities, just like we did, but they didn't put in the 21 law. So I'm a little skeptical about the 21 law because they're hiding and they have to get tanked up before they go out and, all the things that happen as a result of that.
This is probably one of the more salient examples where a neuroscience model really has direct policy level ramifications of what laws get written, what the social norms are, how society operates. What are some other areas where you see, if people accept your lifespan wisdom model, that has direct follow-on consequences for social policy?
Well, another thing that we've done some research on is drug testing in high schools. So this is another effort on the part of adults. It's all well-intentioned to prevent adolescents from even trying a drug. So the thought is if we randomly drug test, and it's done randomly only because the Supreme Court has ruled that you can only do that to a limited degree, and because you can't test everybody without suspicion. That's such a gross violation of privacy. At least you could argue it is. So the Supreme Court has agreed that high schools, any school, can test its kids on a random basis. And we sort of think that's a bad strategy because, first of all, it suggests that we don't trust the kids and that any use at all, if you detected someone having used marijuana 3 months ago and it shows up, because marijuana does stay in your system for quite a while. Alcohol doesn't, ironically. So these drug testing systems will pick up things like marijuana. They won't pick up alcohol, which is a far more serious worry. And if a kid does test positive, it could be because all they did was smoke some marijuana 3 or 4 months ago, and they're not current users, and they're not really at risk of any addiction. They were just exploring. So we think it's not a good strategy. And there's research to suggest that it's an ineffective strategy because what the kids do is they know what drugs are being tested, so they just are sure not to use those drugs during the school year. They use other drugs that won't be detected as easily, including alcohol. And so there's been evidence to the effect that other drugs go up in use and the ones that are tested may go down, but the kids don't report any less concern about those drugs or any less interest in trying them. They just know that if they're in a school that tests, it's not smart to use it during the school year. And so it's really not a very smart strategy. The better strategy would be to, A, watch for kids who might be having problems and get them into treatment. We would advocate just doing surveys and letting kids report on their own if they're having a drug problem or any other mental health problem and make it confidential. And if the school finds out that a student is having a problem, they can then go to them confidentially and suggest, how to get help. Or be on the lookout for kids who are not doing well suddenly, their performance drops, they don't show up, things like that. Go after those kids. But just the kid who's exploring doesn't seem like a very smart way to go, and it's not all that effective either.
Has there been any pushback as you put these papers out and these ideas? Any counterpoints?
Yes. So I will tell you that we had a hard time getting it published. It took us a couple of years. We had at least 5 different reviewers, some of whom read it more than once because we revised it. And so advocates of the imbalance point of view are not very open to alternative interpretations. We finally found the right journal and the right people who would appreciate what we were saying. And so it took a while. Now, I think what will happen, since it just got published and it got some attention, they will now come after us and push back. How they will do that, I'm not sure. But yeah, I'm sure they will. The people who advocate the imbalance model will not be convinced by our review, and they will try to poke holes in the evidence we present. It'll go on, and we'll keep doing research to try to show that we're right and they're wrong. On the other hand, maybe they'll just say, yeah, you're right, and move on. That's a possibility.
Are there people that have sort of built careers around this idea of the imbalance model, that they really have an important dog in the fight, I guess, as far as their own prestige levels?
Absolutely. I mean, it's almost like a cottage industry. People have written books. I won't name names, but I know in talking to some of these people that they love the attention, and they say they could spend their lives talking to various groups, parents and other groups, about the teenage brain and, how do you deal with the teenage brain? There's loads of self-help books about it, and the people who write those do very well. What we're saying, it goes a little contrary because they like to start with the imbalance model and say, yeah, the teenager, the brain is just not developed, and boy, oh boy, does that cause problems.
The macro level of effects of teenagers behaving in risky ways, I mean, nobody's denying that. I mean, that's there one way or the other. And I feel like people could make a pivot and still be able to write books about how to raise your teen.
Sure. And I think this authoritative parenting, which is an idea that's been around for quite a few years, is a very nice way to think about it. And you just build up from there. And so, yeah, these self-help people will find other ways to send their message, I'm sure.
Smart Drug Smarts.
So a big thanks to Dr. Dan Romer for taking the time for that interview. My parents are both teachers, but they straddled the gulf. My mom dealt with young kids and my dad with university students. But there were always a lot of teachers around my family when I was growing up. And there was definitely sort of a special type that elected to be around the middle school and high school years. Like the teachers that intentionally dealt with the teenagers, that was their sweet spot. They were a giving, a forgiving, and just a ballsy group. They definitely sort of had a different flavor to adults that could deal well with teens than the other teachers that were around. So I've got a lot of respect for people like Dr. Romer that keep up to their elbows in teenagerdom throughout their adult life. But I find that frame of looking at the teenage years of being fraught with danger and occasional disaster and misguided plans that go down in balls of flame, but in the service of learning something useful, as long as they're just metaphorical balls of flame. That's an intuitively compelling theory for me, more so than thinking that the human brain has this big backslide period between childhood and adulthood. It sounds like this is still going to be an area of academic fisticuffs for some time to come, but really interesting to hear some of the issues that are still up for discussion, and hopefully informative for all of us that either deal with teens now or at least reflect back on our own teenage years and wonder what the hell was going on then. And we'll keep it vaguely teenager-ish for just a little while longer, looking at teenage roundworms in the ruthless listener retention gimmick.
Smart Drug Smarts, Ruthless Listener Retention Gimmick.
So I found a nice piece of research from earlier in this year that seemed sort of like a complementary story to the one that you just heard about human teenagers. This one looking at neurological differences between juvenile and adult roundworms of the breed C. elegans. C. elegans is kind of the overexposed celebrity of the roundworm world. It appears in all the scientific journals and pretty much everything about it is publicly known. It is well studied because it has only 302 neurons in its entire nervous system compared to some 86 billion in humans, so quite a bit of an easier cat to skin when you're doing neurological studies. And the behavior and mappings of each of these 302 neurons is actually quite well known to science now, making it ideal for study. And one of the things that scientists have seen is that these C. elegans juveniles are not nearly as good at finding their own food as adults. And this is despite the fact that unlike human adults and teens, where the number of neurons actually differs depending on where you're at in the life cycle, for teenager versus adult roundworms, that's not the case. According to this study's senior author Srikanth Chalasani, our research shows that despite having exactly the same genes and neurons as adults, adolescent roundworms have completely different food-seeking preferences and abilities. It's only in adulthood that we finally see the worms become more efficient and competent at finding their food. To get to the bottom of this, the researchers put a chemical named diacetyl, better known to humans as the smell of buttered popcorn, and they placed that at one side of a dish and gave the roundworms a starting point in the center of a dish, so the roundworms could go any way they want, only one of which was actually the correct direction to the drop of buttered popcorn smell. Then, in a series of trials over several days, they looked at the paths that the different roundworms took. The adults hopped right to it. They made a beeline for the smell, whereas the teenage worms kind of hemmed and hawed. Some of them made it over there eventually. Some of them kind of went in loop-de-loops, and some of them never made it at all. Probably anthropomorphizing the worms just a bit too much. The study's first author, Laura Hale, said, "It's like the younger worms are angsty teens. To watch their behavior, it's as though they say, 'Yeah, I know I'm supposed to go over there, but I just don't feel like it.'" The researchers wondered if maybe the adolescent worms' senses just weren't as well honed as the adults, but when they inserted a really bad smell into the environment that they knew the worms wouldn't like, both the young worms and the older worms fled the smell as quickly as possible. The researchers did see different styles of neural activity in the young worms versus the adult worms. With more neural activity going on in the adults, they had 6 additional neurons, 3 neuron pairs, that did fire in concert responding to the food smell. When these neurons were chemically silenced in adult worms, the worms would meander the way that the teenagers did, suggesting that the adult food-seeking behavior results from a complex combination of neural inputs. The researchers suggest that what might be going on here is that the worms are maintaining flexibility in their youth so they can become particularly good at responding to the types of foods that wind up being available in their environment, says Chalasani. These results support the idea that evolution works by making a juvenile plastic to learn a lot of things, then making an adult tune to take advantage of that learning. Instead of merely being rebellious teens, both humans and worms may just be staying flexible to adapt to an unpredictable world.
We like to think of ourselves as a digital speakeasy for brain hackers, but you can call us Smart Drug Smarts.
Okay, so that was it for episode number 198. Thank you for hanging around until the very end. If you enjoyed this episode, you can find everything that we talked about here up online at smartdrugsmarts.com/198. If you missed last week's episode, in 197, I spoke with Dr. Stephen Fleming about metacognition, that is, thinking about thinking. And next week in episode 199, I'm not exactly sure what it's going to be. A couple of viable contenders, but we'll see what pops out of the editing suite. We've got episodes coming up about African trees, prescription stimulants, addictions of a technical and non-technical nature, and a firm counterpunch to the idea that meaningful skill transfer across various domains is basically impossible. A lot of good stuff coming up, but the exact order in which those dominoes are going to fall is subject to chance and tea leaves and other things beyond my control. So you'll just have to come back and see. But I will be back here next Friday as usual. Same time, same podcast, and with that same unflagging commitment to helping you fine-tune the performance of your own brain. Have a great week and stay smart.
You've been listening to the Smart Drug Smarts podcast. Visit us online at www.smartdrugsmarts.com and subscribe to our mailing list to keep your neurons buzzing with the latest in brain optimization. Smart Drug Smarts should be listened to for entertainment purposes only, although some guests on the show are medical doctors, most are not, and the host is just some random guy. Nothing you hear on this podcast or read at smartdrugsmarts.com should be considered medical advice. Consult your doctor and use some damn common sense before doing anything you think might have a lasting impact on your brain.